Welcome. Today, we're going to talk about a really wild idea in problem solving. What if I told you the best way to find the single best answer was to completely stop looking for it?
Yeah, let's just jump right into that paradox. It sounds totally backward, right? Stop trying to solve a problem. But this one simple idea is actually the key to a super powerful new approach, one that finds the best solution by first mapping out all the other ones. So first, let's talk about why our usual way of thinking can get us into trouble. We can call it the trap of perfection.
Okay, check this out. This is a classic example from the research that shows exactly what I mean. It's called the deceptive maze. If you tell a robot, hey, your only job is to get closer to the exit, it's just going to run headfirst into that wall and stay there forever. It gets stuck. The actual best path, the fastest way out, requires the robot to first move away from the goal. It's a perfect illustration of how just gunning for the best solution can literally trap you.
So if charging straight for the goal is a dead end, what's the move? Well, it's about changing the entire game. We're not looking for a single point anymore. We're trying to map the whole territory.
The official name for this strategy is diversity optimization, or DO for short. And the goal here is not to find that one single perfect answer. Nope. Instead, the goal is to find a massive collection of different answers that cover every possible outcome you can think of.
Here's a great way to think about it. A traditional approach is like a mountain climber obsessed with finding the one highest peak on Earth. That's all they care about. But a diversity optimizer, that's more like an old-school explorer, whose mission is to create a complete, detailed map of an entire continent, every mountain, every valley, all the rivers, everything.
Now, this idea of mapping isn't totally new. Researchers have been trying this for a while, but their go-to tool for the job had a really big, critical flaw.
So one of the first big attempts at this was an algorithm called Novelty Search. And it's a pretty clever idea, right? Instead of rewarding an AI for getting closer to a solution, you just reward it for being different, for finding something that's never been seen before. Its only job is to go out and find new, weird stuff.
Let's go back to our explorer analogy. Using novelty search is kind of like trying to map the whole world by just asking the folks in the next village over, if their area is crowded. You're only getting a super local perspective. You might think you found this amazing, undiscovered, empty space, but you could be just over the next hill from a huge city you have no idea about.
And the researchers who designed it even pointed out this weakness. This quote from the paper says it all. The very definition of what counts as new or novel can just completely change every time you discover something.
So this is the key takeaway here. The map that Novelty Search builds is fundamentally unstable. Finding one new thing over here could suddenly make a place that seemed really interesting yesterday totally boring today. The ground is constantly shifting under its feet, which makes it almost impossible for the algorithm to build a good long-term strategy for exploration.
And that brings us to the breakthrough, a new way of doing things that creates a much more stable and much more accurate map of what's possible.
This new algorithm is called Density Descent Search, or DDS, and this slide just nails the difference. Novelty Search was unstable and local. It was like asking your neighbors for directions. DDS is stable and global. It's like you traded your local village guide for a high-tech satellite that gives you a full heat map of the entire planet, showing you exactly where all the unexplored places are in real time.
So how does it pull this off? Well, it's this really elegant 5-step loop. First, it just generates a bunch of random potential solutions. Second, it figures out where those solutions land on our map. Third, and this is the genius part, it uses every single point it's ever found to estimate the population density across the entire map. Fourth, it gives the highest scores to the solutions that landed in the emptiest, least crowded spots. And finally, it adjusts its strategy to start looking for more solutions in those quiet, unexplored areas. It just repeats that over and over.
And the results, they're just incredible. Look at this. On the left, you've got an older algorithm trying to figure out every single position a robot arm can reach. It does okay, but you can see all those gaps and holes. Now look at the right. That's Density Descent Search. It's a nearly perfect, solid circle. It has mapped out the entire space of what's possible with just incredible accuracy.
Or look at this test. On the left, another older method gets completely bogged down exploring the crowded center where all the obvious answers are. But on the right, look at DDS. It's not afraid to push out to the absolute fringes, exploring all the weird, extreme, and unusual solutions that other algorithms completely miss. It fills the map out all the way to the edges.
The raw numbers back it up too. This table shows something called a coverage score. It's basically just what percentage of the map each algorithm was able to explore. On that first task, DDS gets almost 68%, completely blowing Novelty Search's 23% out of the water. And on the robot arm task, get this. DDS hits 80.22% coverage. The absolute maximum theoretically possible score is 80.24%. It came within a hair's breadth of perfectly solving it.
Okay, so the algorithm is clearly a beast. But this is way more than just a cool academic finding. Why does any of this, creating these complete maps of solutions, actually matter in the real world?
It's a totally fair question, right? Why should we care? Is this just about making pretty charts for a research paper?
Well, the applications are actually huge. Think about a robot that gets damaged in the field. Instead of having just one way to limp back to base, a diversity search could give it hundreds of backup plans to try. Or we could use this to have an AI generate thousands of completely new designs for antennas or building materials for us to test out. We could use it to find those super rare, unexpected failure points in things like airplanes or power grids to make them safer. You could even use it to generate endless, creative, and interesting new worlds and levels for video games. It's all about having a whole library of options, not just one plan that might break.
So, I'll just leave you with this final thought. This whole idea, it's not really just about finding a better answer. It's about fundamentally changing the question we ask in the first place. When we shift our goal from finding the best solution to finding every solution, we unlock a whole new way to think about creativity, problem solving, and making our systems more resilient. Just imagine, what other impossible problems could we finally solve if we had a complete map in our hands? Thanks for tuning in.